Hello, in this video I'm going to talk about equations involving inverse trigonometric functions. So by now you've already seen equations that involve circular inverse functions, equations that involve linear functions, and then also equations that involve quadratic functions. Now, when we say something like an equation involving an inverse trigonometric function, we could actually mean something like 6 cosine inverse of x equals to, let's say, pi. Now, simply enough, we can actually say that this actually would tell us that if we were to isolate the cosine inverse function, that you would have cosine inverse of x equals to pi divided by 6. But if you take the cosine inverse on both sides, basically you'll see that this gives you cosine pi over 6 equals to x. But furthermore, that's going to tell you that x equals to root 3 over 2. So that means that the only answer to that equation is x equals root 3 over 2. Now, in either case, it seems a little intuitive that if you want to solve for the value x, that all you need to do is just isolate the inverse function and then just work it from there. Well, that's kind of how these equations would be. So let's work out some of these equations. So like for example, let's say that you have sine inverse of x plus tangent inverse of x equals to 0. Well, one thing that I could do, for example, let's see. So in some cases, we may have to apply the inverse to both sides, but let's see what we have here. So we know that, for example, that if we were to, let's say, isolate the variable, so like, for example, let's say that sine inverse of x is equal to a, then that means that sine of a equals to x. So from there, from there it looks like what we can say is that we have tangent inverse of x equals 2. So here we're going to say that that equals to negative a. So from here, this tells us that we have the following. We have tangent of negative a equals to x. Now, based on our knowledge, we have that that would be negative tangent of a equals to x. Now from here, it's just a matter of kind of putting everything together. For example, I know that from sine of a equals to x, that I have that that's going to be x and that's going to be 1. So that's going to be x squared minus 1. And then we have an a right there. Now, essentially all that that means is that you have the following equation. You have tangent of a is equal to x over radical x squared minus 1. So that's going to be negative x divided by the square root of x squared minus 1. And this equals to x. Now, in either case, one thing that you should make note of is that this equation can be solved. This equation can be solved algebraically if we were to rewrite it as the following. If we rewrite it as the following, such as like x times the square root of x squared minus 1, and then that's going to equal to negative x. So from here, basically we have that that's going to tell us that we have that you have x times the square root of x squared minus 1, and then you have plus 1 equals to 0. But one thing that I'm noticing is that there's no way to solve what's inside the parentheses, because you have that there's no way that you can have that it'll ever equal to 0 accordingly. So thus, you have that the only solution to this equation is x equals to 0. Okay, now if you're having trouble, like let's say for instance you're like, okay, well how did you get x equals to 0? Try to solve the following equation that I just boxed and try to solve it algebraically and then go from there. But you'll see that there is no way that you can actually find an x value that will make this denominator equal to, let's say for example, like negative 1, okay? Because you have the principal square root is always positive, so there's just no way that we can get that equal to negative 1, hence there's no way that this can be 0. So the only answer is x equals to 0. Now that one was actually kind of tough, but we can also work out a similar example. Let me slide on over just so that we have some room. Okay. Now, in this equation, we have that you have arc cosine, or arc sine 2x equals to plus 2 arc cosine x equals to pi. So one thing that we could probably do is say, for example, that arc cosine is equal to, let's say, b, perhaps. So yeah, we'll just say that arc cosine of x is equal to b, which basically means that cosine of b equals to x. Okay, now if that's the case, we have arc sine 2x equals to pi minus 2b. So let's take the sign on both sides, so that way we have the following. We have 2x equals to sine of pi minus 2b. Now from here, one thing that you got to notice is that basically if you expand this, you have sine of pi, then you have cosine of 2b minus, let's see, sine of 2b, and this is going to be, let's see, times cosine of pi. Okay, so this gives us the following equation. It gives us 2x equals to positive sine 2b. Now this is the part that gets a little crazy. You have that sine 2b is actually 2 cosine of a, not cosine of a, cosine of b, and then you have sine of b. Yes, okay, so that's just using the double angle formula. Now, and yeah, if you want to say sine b, cosine b, that's fine too. Now, based on my identity, I have that the x is on the adjacent and the 1 is on the hypotenuse, so that means that the opposite is 1 minus x squared raised to the 1/2, and our angle is b. So, let's see. Now, of course, yeah, the 2's cancels out, and so yeah, you have x equals 2. Okay, so cosine was already established to be just x, so we have x. Then we have sine of b. Sine of b is equal to the square root of 1 minus x squared. Now, it looks like I'm getting basically the exact same equation as before. So I have x minus x times the square root of 1 minus x squared, and this is equal to 0. Now, from here, basically, you have that if you were to reduce this equation or rewrite it, you have x times 1 minus the square root of 1 minus x squared equals to 0. Now, from here, it appears that we have possibly multiple solutions because basically what ends up happening is that we know that x equals to 0, but let's come back to that. So 1 equals to the square root of 1 minus x squared. But in any case, like if I square both sides, I have 1 equals to 1 minus x squared, which basically tells me that x equals to 0. So x equals to 0 for this one, and then x equals to 0 already. So in any case, it appears that the only solution that we do have is x equals to 0. So essentially the previous problems, they both were just 0. But notice that also that, you're coming up with these algebraic equations of which at that point, is just a repeat of, those questions that involve radicals. Now, let's look at these last two, okay? And, if you want to pause and, check out the work from this one, or just rewind and try to reason out, how did I get 0 for both of them, then feel free to, because in that sense, you can try to work it out. Now, in some cases, you may be actually able to sort of eyeball it, where you can just say, oh, well, the only way to get this to be 0 is when sine is 0. So sine of 0 is 0, tangent inverse is 0. So then in that case, the only way to get that is if x is equal to 0. Same thing over here. The only way to get pi is if, for example, that this gave you some multiple of pi. So in that case, that has to be 0. And this right here would be pi over 2. But pi over 2 times 2 is pi. So in that case, it's just 0 also. Now let's try this example right here. Okay, so this example is a little bit better in the sense that we can actually just work this out by, let's see. Well, first off, we know, like, for example, that we can figure out what cosine inverse of -1/2 is. So, for example, we know that, let's see. Okay, so yeah, if we do cosine inverse of -1/2, basically you have that either you can name it a new equation, like you can name it A or B, and then work from there. Let's see. I want to actually see what happens, like if I go ahead and name it something. Like if I name it A, can we go ahead and solve for x from there? It's very possible, but we'll see. Okay, so sine inverse equals, well, it'll be plus A equals to pi. So in that case, you have sine inverse equals to pi minus A. Now, back over here, you have that this expression tells you that cosine of A equals to -1/2. So if I go ahead and I take the inverse on both sides, well, not the inverse, but the sine on both sides, I have x equals to sine pi minus a. So this equals to sine of pi cosine of a, and then let's see, right, okay, so this will give us sine of pi minus sine of pi cosine of a, and then minus sine of a, and then we have cosine of pi. So it looks like, for example, that sine of pi is actually 0. So you just need to find sine of a. Now, basically with sine of a, essentially you have that this is 1, this is 2, and this is root 3. So let's say that sine of a is right there. So sine of a is going to be root 3 over 2. So in that case, that's going to be negative root 3 over 2. And then that's times -1, which is root 3 over 2. So accordingly, we have that this is going to be root 3 over 2 for the solution. So what that means is that if you plug in root 3 over 2, basically, let's see. Basically, like by plugging root 3 over 2 back in, you're gonna get that that's gonna be 60 degrees. So that's pi over 3. But the problem is that let's see. The problem with that is that you have 2 pi over 3. Okay, right. So let's see. So checking our work, we have sine inverse of root 3 over 2 plus cosine inverse of -1/2. So basically sine of inverse of root 3 over 2 is pi over 3, but cosine inverse of -1/2 is 2 pi over 3. Now, when you add those two, you're going to get 3 pi over 3, but that's equal to pi. So it checks out, and the solution is just root 3 over 2. Okay, so yeah, we have that our solution would just be root 3 over 2. Now, if you wanted to do it a little bit differently, you probably would have just said, okay, well, like let's go ahead and rewrite this where we say that that's going to be 2 pi over 3, but then that tells you that sine inverse of x is equal to pi minus 2 pi over 3, which is pi thirds. So in this case, it's almost like a reverse of the previous the very first problem, where you have sine of pi over 3, where x equals to root 3 over 2. Maybe this method would be a little faster, because then in that case you can just say that that's going to be 2 pi over 3. Pi minus 2 pi over 3 is pi thirds. Then you just take the sign on both sides, and then it just gives you root 3 over 2. But that required that you had to have known that the 30-60 triangle is what gave us that result immediately. So in this sense, it helps to still know some of the trig triangles to be able to solve these types of equations. Now, this video is not really inclusive to all types of equations, that involve inverse functions, which I do advise that you do try them out. Now, and let me just go ahead and scroll back over here, and and scroll up a little. That way you can kind of run through like exactly what did I do. I just basically applied where I just isolated the inverse function and then just took the sign on both sides. Sine inverse or sine of sine inverse of x is always just itself, so it's just x. And then from there, you're just expanding using the sum formula. Then from there, it's just simplification where you just get root 3 over 2. And then here is where I checked my work because I actually wasn't too sure due to the fact that in my mind I'm thinking, but it's in the second quadrant, but it worked out in the first, so that part didn't make sense. So I had to work it out just to be sure, and it apparently did. Um, okay, so we applied the sum difference formula. Now, if we go ahead and we look to this new equation over here, okay, so this is actually one of these special identities that you will actually be using in Calculus 1, 2, and so on. So this is actually a little interesting because when I first saw this equation, in my mind I'm thinking there's got to be an algebraic way that I can actually solve this. And I didn't realize until then that, once I was able to kind of notice that, well, based on the definition, first off, I know that basically sine inverse of x is going to range. It's going to range from negative pi over 2 to pi over 2. Okay, so in this case, like I know that the answers could be inclusive to those right there. But then I also know that with cosine inverse of x, cosine inverse of x is going to range from basically from 0 to pi. So from there, that's where I just kind of got interested in like, okay, but how is this possible that like if I'm adding these two, it's going to tell me that it's going to say pi over 2, which in this case, if we were to manipulate those equations, basically it would just give us a true statement, like negative pi over 2, pi over 2, and then it gives us 3 pi halves, which, okay, this doesn't really help me because then I'm like, okay, well, what does that mean? So the way that I thought about it when I first saw this problem is that I said, what if sine inverse of x is equal to a? And then what if I said that cosine inverse of x is equal to b? From there, I have the following expression, a plus b equals to pi over 2. So in this case, I have two angles of which must add up to pi over 2. But the only way for that to happen is if and only if both are acute angles, which essentially, if you kind of look at the definition of sine inverse of x from negative pi over 2 to pi over 2, in some way, they are actually going to be acute angles no matter what. So in this case, this would actually imply that for x, if as long as a is so a is somewhere between negative pi over 2 to pi over 2, and b is from 0 to pi, that means that this equation right here is actually going to be true. It's going to be true such that negative 1 is less than or equal to x, and that's less than or equal to 1. Because of the fact that, we have that all angles between negative pi over 2 to pi over 2 will work. All angles between um, between b, well, yeah, all angles between 0 and pi radians, those will work too. But the main thing that determines the truth to this to that statement is if and only if x is between -1 and 1. So what that means is that you have multiple solutions along the real line from -1 to 1. And that's kind of confusing in a way, and it's something that you may not even be asked to actually solve necessarily, because in that case it actually might prove to be very difficult. However, there are ways to prove what it equals. Like, for example, like if you didn't know that it equaled pi over 2, the question might be uh, either show what value does it equal, or show what value, or show that it equals to pi over 2, but it never will actually tell you what x is. But I can tell you that x is basically it's a real number between -1 and 1, with the integer values at the endpoints and also at 0. I mean, you can try any, and it's actually kind of interesting because, like, if you try like cosine inverse of 1/2 plus plus sine inverse of 1/2 equals to pi over 2, basically I know that that's going to be pi over 3 plus pi over 6 equals to pi over 2. But then you just need to basically just combine like terms using common denominators, which you just multiply this by 2 over 2, which gives you 3 pi over 6, which is actually equal to not pi over 6, but pi over 2. So that means that, yeah, you can choose any value in between x, and you'll always get that it's going to equal to pi over 2. Okay, so that's going to be it for this module. Just be sure that you do practice any other types of equations that involve inverse functions. But if anything, you always want to be sure to apply the definition at all times. So, you know, if you would like to try examples, you can always like try simple examples first off, so that way you can kind of understand like how do those equations even work. So, you know, like you could have something as simple as um, like let's say for example that you have cosine inverse of x equals to sine inverse of x. So, you know, in this case, you would have to basically just say, okay, well, that equals to maybe like b, and that equals to sine inverse of x, which that means by definition that that gives you that sine of b is equal to x. So in that case, you know, you would just have to like kind of figure out from there, you know, what x would have to equal, or if it's even possible. So for instance, like if I was going to use like my graphing calculator, I could probably solve, for example, that type of question and see like if it does have any solutions. So, you know, I didn't really talk about this aspect that much, like, you know, like using the graphing calculator to solve for these types of equations, but you can. So for example, it tells you that it has a solution at pi over 4 or at x equals root 2 over 2. Um, so in this case, yeah, you have that. That's going to tell you that um, yeah, that's going to tell you that um, that if you were to apply the definition on both sides, yeah, basically you would figure out that essentially this is actually where the two would have to equal. So eventually you're going to come up with that x is equal to cosine x is equal to cosine of b. So in this case, that's also telling you that basically like sine of b equals to cosine of b, but that's only if tangent of b equals to 1. So in that case, that tells you that b has to be equal to, yeah, b has to be equal to pi over 2, or not pi over 2, but pi over 4. So in that case, the value that gives you pi over 4 for b is actually x equals to, so yeah, you would have to kind of backtrack, because then you'd say that b equals, well, yeah, you would have to say sine of pi over 4 equals to root 2 over 2. So b is equal to root 2 over 2. Okay, so in a way, I kind of worked it out like using both the graphing calculator and also a little bit of algebra in this case. But that's kind of like, just like the whole idea behind this, that you can actually solve most of these problems algebraically, and just by using the original definitions.